Hey everyone, Rob here from Rising Edge Industries, and in this video we're going to cover a little demonstration of our beta data tool to look at and display CSV files, do a little manipulation and some analysis. So we won't run through a full test sequence. We'll start with the CSV files that are already downloaded. We did a test run with two 60K and DevCo accelerometers on channels 1 and 2. Channel 3 is a sine wave coming out of our signal generator. That's 100 millivolts peak to peak, and there are two 180 degrees out of phase sine waves. Channel 4 is going to be the 1000G 7264H in DevCo accelerometer, the gain of 30. So the configuration, we've got channel 1 and 2 have gains of 100 because the accels are so sensitive, and a gain of 30 on channel 4, the 1K. And so we've covered a little bit of what the controls do here. Any deeper dive will be in our more detailed video series, since this is just a quick overview. But I wanted to put together something that shows what the data looks like, how you get it. So you just press the download button, it downloads the CSV for you in a CSV format. And so we'll open up the little plotting tool, and this is what it looks like. So I'll put that up there. And so it just loads two sine waves in the tabs. So the tool has a file browser on the left, controls on the bottom, and the display frame here in the kind of middle right. And so all you have to do is browse to the root directory of the configuration application we talked about in previous videos. Go to download the serial number. Here you can pick between ADC code or voltage value data files. They're both the same, so they'll have, we did two runs, data 1 and data 2, so they're both in here, just in different formats. So we'll look at the data 2, we'll look at the data 1 first actually, and we'll just show a little bit of clipping that happens. So this is the input for channel 1, they're tab separated. Channel 2, channel 3 is a sine wave. We can zoom in and just verify that. You can see there's a sine wave there. And so first, real quick, we'll look at channel 4. So channel 4, the DC offset of the channel, which we discussed in a previous video, so check that out if you're not familiar with how this applies to the data recorder. But you can see there's clipping in this one at 0 because the offset wasn't set high enough. So what we did, we went over this quick before, but we used offset calibration, heads up display, and selected channel 4 and just walked the target up just like this. So now our DC offset is 30 ADC codes higher. We closed it out, ran a second data capture, and that's what the data 2 file is. And so if we open that up, we can see channel 1 is 160K, another 60K sine waves here from the signal generator, and now we have a non-clipping waveform from our 1000G 7264H. So this is the file browser. The controls are down here. This application is still being built out. It's currently released just in beta form. And so we'll look at the waveforms a little bit. These are the 60Ks. So this kind of provides, as I mentioned in a previous video, a good platform that's pretty much plug and play lab use to get some of these more challenging sensors up and running. You can see that there's a few controls down here for the plot, but looking at this, we can see the oscillations and characteristics of the waveform. Can zoom out and see the dampening, and because these are undamped accels, there's more ringing in these. The 1000G 7264H is a damped accel, and so look at these two. And so we'll look at that one next. This one, you see a little less noise, a little less ringing from the device. It's definitely smoother. You can zoom in as much as you want, and I guess the first thing to point out is that although we get close to 0, we're not quite clipping with this. Lowest point is above 25 millivolts, so our DC offset move for this channel has helped out a lot. And so if we zoom in and look at the first couple high points or impulses here, we can also maximize this, and we can also close our file browser and now move the waveform around a little bit and see. You can see in great detail. We recorded at 125,000 samples per second, so the resolution of this should be really, really good. You can see it's a very smooth waveform, even though we're zoomed in. That x-axis is time, the y-axis here is voltage. And so this is just a quick result of the plot that we'd expect, and some data acquisition from sensors. We can also go to channel 3 and zoom in here. This is just a standard sine wave here. And we can touch quickly on some of the controls. So for example, if we look at the Damptic cell, we can use some of the simple controls, detect peak, and we see we've got a dot at the highest peak here. We can toggle that on and off. We also have cursors, so we can do some basic waveform measurements, so enable cursors, and then you just click on the waveform, and we have a red and green cursor, so if you want to measure peak values, we see the measurement data here, Y values here, 1.665, 2.52, and X values in time down here for each cursor. So C1 is cursor 1, C2 is cursor 2. You can toggle between which cursors you drag around. There's a dot that helps display this a little better. And so now we'll switch here. So you can take some quick, easy measurements, and there's also some SRS calculations, high pass filtering, and FFT, and we can get into those on a different video. The file browser you can bring back with the file browser button. So this is a tool we're still building out, adding quite a bit of functionality every month. But I wanted to get a video out just to show some of the data and the results from our last couple of videos where we're using the data recorder, discussing all of its features, parameters, and some of the key features are just really simple, such as providing a way to get a sensor up and running quickly without ordering a lot of complex equipment. These are pretty much plug and play. You can control the gains, shift them around, and as we can see from the first plot here, you just double click or you can go to open file. But one of the most pertinent things that couples into one of our previous videos is just to show how you can walk the DC offset of the product individually for each channel up and down to prevent things like clipping. So you can walk this up just like we did here, so you get the most out of your y-axis. So your undershoot is just above 0, and you have the maximum range for your overshoot. So here we still have some headroom. We're only at about 2.5 volts, but this can be easily adjusted in just a couple seconds with the feature we've touched on before, which is just this. So to solve that clipping problem, all we did was go in here, set a new target to move the DC bias of the channel 4 analog channel up a little bit, and reset the recorder, and we were ready to capture a new feature, we were ready to capture a new waveform. And this was all captured in burst mode, so the recorder was running fairly autonomously. It's just set up, click start, and then once it saw channel 4, which it was set up to monitor, exceed our voltage threshold on this first pulse here, it triggers itself. And so just to point out what was happening quickly in burst mode, we'll go over this in our detailed series, but this is pencil. So from here to here is our pre-trigger circular buffer, and from our trigger point here over is our post-trigger buffer. and the event falls right in the middle. So we've got something that looks like this. Here is pre-trigger memory. Oops. Pre-trigger memory. This is post-trigger memory section. So that makes it a little more clear. Some of the things we were talking about previously could be a little confusing. So this is a picture of what is actually happening with the memory space. And this was a data capture that was set to run for 600 milliseconds. So we'll look over here. Browser. So you can see over here our data capture in post-trigger memory is set to run for 600 milliseconds at our maximum data rates, and the threshold triggering set down here. So that's pretty much all we want to cover for this video. I hope that adds some visibility into what to expect from the recorder, how to look at the data, do some quick analysis, and all these data files are just simple text files, so it's very easy. We'll go into a quick data file just to show that these are really simple text files that you can open and process in anything from Excel to custom MATLAB, your own Python. And keep in mind that all the columns, this is column 1 is the time step. This is channel 1, channel 2, channel 3, channel 4, and we can also look at the ADC codes. This is exactly the same. The only difference is that it is it's recorded same time column here, that hasn't changed, but now this is all in ADC codes. So you get the raw ADC codes. You can post-process these yourself as well. So these two files come with every download. And I think that pretty much covers everything for this video. Thanks for watching, and we'll see you later.